Hello everyone, this is Venu Madhav. I am an embedded systems intern at EMERTXE Information Technologies. During my internship, I worked on a microwave oven simulation project using a microcontroller. In this video, I will give you an overview of all the important topics that I learned during my internship, and I will also take you through the project implementation that I developed. So let's get started with the presentation. Table of contents. The following are the topics that we are going to discuss in this video. Introduction, embedded system, microcontroller, design and board selection, tools used, project implementation, conclusion. Introduction. A microwave oven automates the process of heating and cooking food using controlled microwave energy through a sequence of operations such as timing, heating, and stopping. It operates using key components like a magnetron, turnable motor, cooling fan, door sensors, and control panel to manage the cooking cycle. To ensure efficiency, safety, and programmability, a microcontroller-based embedded system is essential for real-time control of heating time and motor operation, monitoring sensors, example door status and timer, user interface and cooking cycle management. This project implements these functions using embedded C on the PIC16F877A microcontroller, demonstrating how software and hardware work together in a real-world appliance. Embedded system. What is embedded system? An embedded system is a microcontroller-based software-hardware system designed to perform specific tasks or functions. Unlike general-purpose computers, embedded systems are built to optimize performance, reliability, and resource efficiency for a particular application. Core components: microcontroller or microprocessor, software code written in embedded C. Input devices such as sensors and switches. Output devices include LCD, buzzer, motor, and relays, etc. Power supply and timers for real-time control. Examples of embedded systems are washing machines, microwave ovens, printers, automotive ECUs, and industrial controllers, etc. Why embedded system in microwave ovens? Precision control. Timers and interrupts allow accurate control of heating time, turnable motor, and cooling fan. Customization. Multiple cooking modes reheat, defrost, cook using keypad inputs and control logic. Automation. Executes the complete cooking cycle automatically without continuous user input. Cost effective. Minimal hardware with reusable microcontroller logic. Safety. Monitors door status, temperature, and provides alerts using buzzer. Embedded C Basics. Embedded C is a set of language extensions for the C programming language that supports embedded processors. It is used to write low-level hardware interfacing code for microcontrollers. Key characteristics include efficiency, minimal resource usage, portability, runs across microcontrollers, real-time execution, works with timers and interrupts. In this project, embedded C is used to control microwave oven logic such as selecting and switching between cooking modes, displaying status on CLCD, controlling magnetron, turntable motor, cooling fan, and buzzer. Embedded C keywords. Keywords are reserved words in C that have special meaning and cannot be used for identifiers like variable names or functions. The following table shows the keywords that are available in C. Embedded C data types. Data types define the type and size of data that can be stored in a variable. Choosing the correct data type is important for memory efficiency and proper operation in embedded systems. Here is the classification of data types in C. Data types are categorized into three classes: basic data types, derived data types, user defined data types. Embedded C operators. In C, operators are special symbols used to perform operations on variables and values. They are essential for creating expressions and implementing logic in embedded systems. The following are the operators available in C: unary operators, arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and ternary or conditional operators. Embedded C conditional statements. Conditional statements are decision-making structures in C. They check if a certain condition is true or false and then execute a block of code accordingly. Common conditional statements in C include if else, if, nested if, the switch case, and the ternary operator. Microcontroller. What is a microcontroller? A microcontroller is a compact integrated circuit designed to execute specific tasks in embedded systems. Unlike general purpose computers, which can run multiple programs, microcontrollers are dedicated to perform one specific task repeatedly and efficiently. It combines a processor, memory, and peripherals on a single chip. Key characteristics include used in automation and control systems, programmed using languages like embedded C, controls sensors, actuators, displays, and more. Design and board selection. PIC16F877A microcontroller. The PIC microcontroller is a part of Microchip's mid-range 8-bit family and is ideal for beginners due to its rich feature set and ease of use. It uses a modified Harvard architecture which has separate program and data memory buses, enhancing speed and efficiency. Key characteristics: 8-bit microcontroller from Microchip technology, operating frequency up to 20 MHz, memory 14 KB flash memory, 368 bytes of RAM, 256 bytes of EEPROM, I/O ports, 33 programmable I/O pins, and 5 ports, port A to port E, 3 timers, communication modes, USART, I2C, and SPI. Here is the pin diagram of PIC16F877A microcontroller. Here is the block diagram of our project. Here you can see that the PIC16F877A microcontroller along with all the required peripherals. Interrupts. What is an interrupt? An interrupt is a signal that pauses normal program flow to execute urgent tasks. After the interrupt service, normal execution resumes. Why use interrupts? Immediate response to start and stop buttons. Accurate timing with timer interrupts. Efficient multitasking. External interrupt used for detecting start and stop buttons. Responding immediately to user input. Timer interrupt used for generating accurate delays without blocking code. Triggered by timer zero overflow. Timers in PIC16F877A microcontroller. The PIC16F877A has three timers: timer 0, 8-bit, timer 1, 16-bit, and timer 2, 8-bit with a built-in prescaler and postscaler, each serving different timing and counting purposes. These timers can operate as timers counting internal clock pulses or counters counting external events, making them useful for delays, event counting, and PWM generation. Each timer includes prescaler options, allowing us to divide the input clock and adjust the timing interval, which is crucial for precise control in time-sensitive applications. CLCD in PIC16F877A microcontroller. The CLCD is typically interfaced with PIC16F877A microcontroller using a 4-bit or 8-bit parallel communication mode via port B or port D, enabling efficient data and command transfer. The PIC16F877A with sufficient I/O pins and stable timing control using its timers makes it ideal for displaying messages, sensor values, or system status on the LCD in embedded applications like a microwave oven interface. Tools used: MPLAB IDE. MPLAB IDE is a free cross-platform integrated development environment for programming PIC, DSPIC, AVR, and SAM microcontrollers. It provides powerful features like code editing, debugging, simulation, and project management, all within a user-friendly interface. XE8 compiler. XE8 compiler is a C compiler specifically for 8-bit PIC and AVR microcontrollers. It is optimized for high performance and supports integration with MPLAB IDE for efficient code development and debugging. PIC Simulation Lab. PIC Simulation Lab is a graphical simulator designed for simulating PIC microcontroller based circuits and interfacing them with real or virtual hardware. It allows users to test and debug embedded applications without physical hardware, supporting integration with compilers like MPLAB XE8. Project implementation. Conclusion. Through this internship, I was able to understand the importance of C programming in embedded systems, understand various types of embedded systems, and got to know where each type of embedded system should be used. Use various tools to implement a simulation of a microwave oven using microcontroller PIC16F877A. Thank you.